So the weird thing is, although I've replaced that chip, the behaviour hasn't changed at all. Oh, unbelievable. Okay, let's reconnect onto that chip with the scope again, repeat the same test and see if we get anything different. Right, let's try this again. Again with nothing on the leads. So I should try and do all ranges. Let's push the button. This should be doing range A, B, C and D. Push the button. What do we get? There we go. A, B, C and D. All there. Right, A, B, C, D. So that's now proving that yes, there was definitely a problem. So let's shift the D onto the next one over, into the E. Recheck that. The green should move over one. It has. Go on to the F. Should move over by one again. It has. Go on to the G. Should move over one more again. It has. So we definitely did have a problem there. There's no doubt about that. Let's go to, which was H. Should move over one more. It has. Then on to I. Should move over another one. It has. And then on to J. Yep, okay. So that's confirmed that yes, the counter was definitely the problem there. Or at least one of the problems here. That's now working correctly. We've actually found a problem finally after many days of tinkering with this thing and fixed one problem. However, it hasn't solved the problem with the actual unit, which is the weird part. So now I'm actually just testing a capacitor and showing this display. Yes, this is a 100 microfarad and this is what I'm getting here. So it's range A, B and then C. So it's gone down to range C on a 100 microfarad. So I've hooked up a 33 microfarad but should go to range D. Let's try it. D. It's gone past range D. It's gone further than that. Okay, so range D is triggering, but it's going below that. You can see it's then resetting over here somewhere. So what range is actually going down to? We need to find out what it's actually going down to, because that's not right. So let's go down to D, E, F. Let's go down to F or G. Let's go down to G, because I think it's dropping down by 3 ranges. Push that. No, it's not that one. So, what was it? H, was it? A, B, C, D, E, F. Yeah, it's on F now. Let's try F. There we go. That's dropping down to range F. Something there is telling it to go to F, so there's still a second problem, but at least now we know that yes, the ranges are indeed working, whereas before they weren't. But there's still another problem somewhere. So although replacing the IC didn't fix the ranging issue, as in it's still going into the wrong ranges for those value capacitors, it has fixed the problem. So I just looked at some more things. The one issue this had was a leakage mode, the high current leakage, for doing big caps like this one. Right, it's 35 volt cap, 10,000 microfarad. So if I do a measurement on that, it should show up actually. Right, 10,000. So it's actually measuring just fine. Leakage will now actually work. Whereas before it wouldn't actually do that, it would just sit there flashing the entire time. So it has actually fixed something. It's fixed the leakage mode. So that's good. Go to 25 volt. I said it's fixed the leakage mode. There we go. So that is actually working. Now it's quite a large cap, this one, so it's not surprising it's taken a bit of effort to get there. If I change the other side, it's the lower current version, it says something different completely. So that's good. I'm happy about that. We've got one problem fixed. The leakage is now working correctly. Whether it's accurate, I don't know. I'm going to figure that bit out later on. But at least now it's functioning. But we still have an issue where it doesn't go to the correct ranges. Range A, B and C are all correct. They work, at least on capacitance. Dead inductance, I haven't looked at that side yet, not properly. I mean, we could chuck an inductor on here. I've got one sitting here which I was playing with before. It's the 4.7, I think it is. Yeah, 4.7 microhenry. We'll stick that on there so it comes up. 4.7, perfect. So, yeah, that's good. That inductance one's working alright, but at least that particular ranges. I need to think about why it's shifting ranges down when it shouldn't be shifting down. Now, this is using counters, and so it does a count, gets the 90 counts or not, and it changes ranges as required. It could be an issue there. It could be a threshold issue where the voltage is just a bit on the flaky side and it could be causing multiple pulses on a clock pin. Could be something like that. I need to look into this now, think about a plan of action, but I'm just pleased now that I found one problem and fixed one problem. It's taken me forever to get there, but... Right, so now I'm probing on IC20 and IC21, which are comparators. One of these has 0.5 volts on it, and the other one has about 3.5 volts. And they are slightly adjustable depending on which range it's in. So range A will be slightly different, and range J will also be slightly different compared to the others. So there is a bit of adjustment there. There's a transistor switches and something else, and there's like a diode feeding and stuff from J in range J, so it can vary a little bit. So the range J one affects the 0.5 volt comparator, and the range A affects the 3.5 volt comparator. I'm just sort of probing this to try and see what's going on with these comparators. I mean, are these voltages it's getting correct, which may explain why the ranging is wrong. Because if it's not getting the correct responses on these comparators, then it won't go to the correct ranges at the right time, because it depends on the timing of these comparators. So it measures the thresholds of the 0.5 volt and the 3.5 volt point, and those go through some gates, and that then turns the pulse time on and off, basically, depending on the time between those two thresholds. So the longer it takes to charge up, the more counts it will do in order to get those pulses. And so a smaller capacitor will be less pulses because it's got a shorter time to charge. That's what it's based upon. I'm just trying to sort of monitor this section now to see, is there an issue with these comparators. I'm basically going to try and start at the beginning of where it measures these now. Now I know the ranging's working, I can look at these comparators and see what's going on properly here. Is this right? Are the thresholds correct? That kind of thing. Does it look like it's behaving like it's supposed to behave? So I'll show you the scope screen now. So this waveform right here, this is based on a 1000 microfarad capacitor. So you can see the thresholds are changing here between 3.6 volts and 2.4 volts in that range. So this is using those two channels. So you can see these thresholds on channel 1, say 3.6 and 2.4 volts. So it's 2.4 at the lowest point, 3.6 at its highest when it's taken a sample, which is quite interesting the way it's doing that switching. But that's because it's got that range A switching. So the lower one here, the 2.4, that's the range A, because it's got a transistor which pulls that input down. So I'm testing on pin 2. So that transistor pulls pin 2 down through the resistor to lower that voltage slightly. Obviously, so it doesn't take forever to do a sample. So it's doing that to compensate. And then when it goes to the range B, it switches that transistor off and the voltage goes up. So I think that's the range B and that's the range A. I need to verify that, but that's what I think's happening. Let's do a 100 microfarad, because that's range C. So that's range C. So it's going from A into C. That's behaving. Right, it's doing that 3.6 volt threshold. So then we go range D, and we'll see what we get there. This is what should be range D. It's a range D capacitor. What do we get? Voltage is correct, 3.6. So that's at least behaving. The channel 2 here, I've got a 500 millivolts of division, and that's one division, which means that threshold there is about right as well. So at least the comparator references are correct. I'm going to change these connections around now and look at the actual inputs and see what they're doing. So I'm going to go to pin 3 of each comparator, which are what comes from the capacitor. And they should be similar. Okay, that's hooked up. Those little spikes in here, that's interesting. Okay, let's do a test. And that's what we're seeing, there's lots of little spikes. So this is in range D, which isn't working correctly. Alright, that's interesting. Let's go to range C again, what we did just now. Push that button. There you go, getting 3 spikes. You might drop channel 2 down a bit, make it a bit easier to see it. Oh, too much. Just look at there. Don't forget the resolution on this 500 millivolts division rather than the other one, which is 2 volts of division. So it's going to shoot up. And again there, so you go. This is on range B capacitor. So, I mean, those levels are looking okay. It's doing the levels. But it's also interesting to see those little spikes inside there. without a test happening. See all these? What are they there? So it's probably just a pulse on something else. If I do a leakage test, yeah, it's doing that from leakage test. If I do a value test, disappears the slopes. So there's a little screw wave in there. I wonder if that matters. I wonder it's probably from a reset pulse or something somewhere else in the system. But it's 5 volts pulse. If I take the capacitor off, nothing. Okay, it shouldn't be because it's disconnected from circuit. Well, the levels are correct. The reference levels look about right to me. I'm going to keep looking. So one observation I've got is that if I have a capacitor which is quite large, which is in the range A group, it just does one big pulse, one pulse after another. If I do one which is in the group for range B, let me grab that one. This is on a fairly slow time base, 5 milliseconds of vision. You see you've got groups of 2 pulses. Alright, so you've got 2 pulses which are repeated. Small one, big one, small one, big one. Okay, you see that. So that's 2 pulses which would be range B. If I do one for range C, do this one again, I can probably speed the time base up in a second. Just want to do the same one for this. You see 3 pulses there. So you've got 3 pulses. So that's range C, 3 pulses. So if I do what should be range D, you'd expect to see 4 pulses, wouldn't you? We are seeing 6 pulses. And this is out by 2 ranges. So we should be seeing 4, we're getting 6. This is also confirming that yes, we're stepping 2 ranges further than it should be, which is interesting. So let's try range E. It should be range E, so it should be 5 pulses on this one. This is at 1 microfarad. So this one should be the next range. This one should be in range E. So we should get 5 pulses. I bet we get 7. We're getting pulses, but they're looking a bit weird. And we're getting 7 pulses. As expected, too many. So now I've got a capacitor which should be range F, which is a 0.47 microfarad. So this one should be giving, what, 6 pulses? There we go. 2, 4, 6, 8, 10 pulses. And this one is saying no range. So this one's completely out of whack. So that gives the same as you would get with having no capacitor. No capacitor on there now. We're getting there 2, 4, 6. Oh, lost count. 2, 4, 6, 8, 10. Yep. So it's exactly the same. A 4.47 and no capacitor results in the same number of pulses. So yeah, something's doing it right there. So I think I've just had an idea here. This is in range D, or at least it should be in range D. So this is switching off TR20 and TR21. When it's low, that's active. When it's high, that's off. Right? So that's on, that's off. So it's turning off that one there, which is TR20. So that's TR20, that's TR21. And all we're seeing is these little pulses here, which seems to be odd. This should be in range D, right? This is a 10 microfarad cap. If I put in a larger cap, this is a 100 microfarad, and do that again, we'll see that the transistor here is on, so 20 is on, 21 is off, and we're getting 3 pulses like this, which are actually like shaped waveforms like they should be. So I actually think that that transistor, although it's been told to turn on, it isn't actually doing it, because we're not getting a waveform shape there at all. So I go back onto that 10 microfarad again, push it again. See, when that goes low, we should be getting a nice waveform shape there. I mean, you are getting something, but we're getting way too many pulses. And it just doesn't quite seem right to me, because it doesn't match what we've got before. So I was doing pulses before. It goes, oh no, that hasn't made the range. So it's changed ranges at this point here, and done 3 more pulses, then change ranges again. I'm suspicious maybe this transistor is not switching. Although it's been told to switch, this is the base terminal. So I might actually just quickly look at the collector and see what's going on there. See if it's actually showing up. But I knew, actually, it should be, because this is the collector. I don't know, I'm just suspicious maybe that's not switching, because it's down by 2 to 3 ranges depending on what we're actually doing. It's almost like that transistor's not turning on and it's defaulting to the next range down, so then it's creating the extra pulses. That's where my head's going right now. So I'm thinking that TR21 might not be switching on. But I don't know. I'd have to think about it. I might just swap it out with another PMP device, anything I've got laying around, and see if anything changes. So I've taken that device out. Here it is. Let's test it. Yeah, it seems to think it's okay. Well, that's kind of annoying. Damn. Now, the interesting thing is, let's see what happens when I actually go to retest this. I've got everything hooked up still with the same capacitor. So I've taken that transistor out and it's behaving basically exactly the same way, except that this voltage here is dropping lower. But the actual behaviour here is exactly the same. So the voltage is dropping lower because there's no drain through the actual transistor. The transistor's not trying to limit it to that voltage. So it's just going to drop right down. It's still being pulled up by the transistor. So that's not surprising that voltage has dropped. So it's doing something, but the actual behaviour hasn't changed. The reading on the front hasn't changed. It's almost like that transistor was not doing anything. Alright, so I've tacked in another transistor, which is a KSA733. It's got the same pin out. Specs aren't quite the same. It can't handle quite as much current, that kind of stuff. But it should be good enough to see what's going on. As you can see, I've got a sample here. Let's just push a test button again and you can see what we're getting. So it's very similar to what we were getting before the first time around. The voltage here is about the same as it was, 4.1 to 4.2, and we're still getting the same pulses. So swapping that transistor out didn't change anything. It's not that transistor, it's something else. I just expected more of a difference in here with these pulses, but obviously I can put the original one back in again because it tested fine. Substituting didn't change anything, so I'm going to put the original one back in again. So there goes that idea. Unfortunately that didn't work. So I was thinking about this and that my logic was backwards. Now what's actually happened? Now I was absolutely certain that that transistor which we tested to be perfectly fine, was definitely working okay, is the one which was bad. I was thinking, right, that transistor's not turning on. I got it backwards. It wasn't that transistor wasn't turning on, it's that TR20 isn't turning off. Now think about this, the actual pulses, the pulses were too short, which means, because it's an RC network, don't forget the C is the one you're testing, this is the RE, is the resistance side is inside the unit. The higher the current through there, the shorter the time, okay, because you're changing the resistance within the unit. Lower resistance means a faster charge up time, which means a shorter pulse. So I was thinking, hold on, I've got this wrong. It's not the transistor that which controls that stage, it's the other transistor which is potentially still turned on or leaky, because that's allowing too much current to pass through. And because it's one stage above, when it does this test for the range D onwards, well, D through to, was it D, E, F, G? Is it? Yeah, for range it covers. And it's got potentially a current from the one above it. It thinks it's a smaller capacitor than it is because it's not within that range. It's within the bottom range because the excess current being applied. 10 times the current, or whatever it may be. I don't even calculate what the current actually is, but I realised, okay, I'm thinking about this backwards, so I need to look at TR20 and see if that one's turning off. Now obviously we did look at the waveform and see the control signal's turning off, but that doesn't mean the transistor's turning off. So I pulled that transistor out, which is here, and take a look. It thinks it's a dual diode junction. Well, that's not right, is it? It's supposed to be a transistor. So this thing is not working. So what I've done is I've temporarily installed a KSA733, which is another PNP transistor. It's similar enough, I suppose. It's not wonderful. In this particular range, it's probably okay because it's got a big resistor there. It's got 10k resistance in series with it. It's a bit less critical, so it's a bit more tolerant, I think. So I think I can actually probably get away with using this device. I have ordered the correct device, but it's going to take a little while to get here. You know, 2 or 3 weeks, maybe a month. So I'm going to not wait for it. I'm just going to use the one I've got, but I'm going to demonstrate what it's doing. Is it going to work? It is. No, 10.4, and that's with that same 10 microfarad capacitor. That actually worked. Now I'm going to show you the scope. So here's the scope. Let's actually push the button and look at the waveform. Now that is more like what I was expecting. That long pulse like that long slope up. That's what I was expecting to see. I wasn't expecting to see this, I was expecting to see this. So that's the higher range, that's the middle range. Now I actually bet that if I got an even smaller capacitor and went down to another range, you would see a few slopes instead. Let's try that. So this is the slope setup from a 0.1 microfarad capacitor. See, it's very different. So it's getting towards spikes again, right? And it's got a few of them. So as it's going through each internal range within that block, it's going to that. So I need to do a capacitor which is on range, is it D, E, F, G, H, I or J. So it's 3 more ranges. So I need to go an even smaller capacitor which will go below that, should then see some slopes after these pulses. So let's try that. So I'll just put in a 6.8 nanofarad cap, and as you can see we are getting that. Let's do another sample, get it on screen. Here we go. So there's the original pulses we're getting here. There's that big second range. That range is finishing because it's gone out, and then there's the capacitor sloping up. So that's exactly what I was expecting to see. So that's working, that's good. So there's one pulse for each range it goes through. So that's perfect. That is working correctly now. So if you're ever unsure about what you should be seeing at the actual capacitor itself, I suppose, because that's basically where this is, you should be seeing it go through the ranges on the capacitor. You should see that. So it's probably a nice test. If you do have a scope like this line here, so channel 3 here, that is hooked up to the junction of 2 resistors, which would be really easy to scope and quickly check this particular issue. So that would be on the junction of R91. Hold on, I can't see what I'm looking at here. Also, I did find there's an error on the diagrams. There's 2 R113s. One's a fixed resistor, one's a variable resistor. Watch out for that. Anyway, I'm on the junction of R91 and R113, the fixed resistors, which are 2 resistors side by side, which I'll show you in a second. But that's what will give you these. So if I change to a different capacitor, let's go back to still 1 microfarad. Obviously you're scaling on your time base on the scope will matter. So again, here we go. Right, it's going through 2 ranges. Stepping through 2 ranges in that second block. So now we get the first block is A, B, C, and your second block is D, E, F, G, and then you've got your third block. So it tells you which block it's working in, which is great. Now I understand that better, I can explain that to you, I can do that. So here's my probing. I've got some little flying lead probes in here. So I've got one probe here, which is channel 1. That's going onto the TR20 base, just there, and that resistor. Right, that's the TR20 base, which you can see on scope. Another flying lead down here, which is going onto the base of TR21, just down there. And then channel 3, this probe here is clipped onto those resistors down there. See those 2 red ones? So it's R91, that's a junction between R91 and the one above it is R113. See that? So that's a junction, you can clip on either one of those. But that's where you want to check for that particular feature, to see if it's actually matching what should be there. And as expected, these leads will now zero out. What you do to do this, to set this up, so you've got the inductance and the capacitance set up correctly. You short the leads together, do the inductance value, adjust the knob on the front, so you get 0 on the front. And then open the leads, do the capacitor value, and you adjust the trimmer on the back here. Smarter's LC trimmer, as the LC balance or something. And you adjust that one to get the capacitance right. And if you're lucky, your leads are low enough capacitance so you can zero it. These ones work, so that's quite good. Now I'm going to try a low value capacitor and see how close it is. Alright, let's try the 150 picofarad first. These are ceramic caps, so there'll be a bit of variation there potentially as well. Let's try that. 122, I don't know. Let's try them on my LCR meter here. Well, these are very low value, so my meter's not calibrated, so let's see if we've got anything ballpark. That's 141. So it may need calibrating anyway. I don't think I need to adjust this after the abuse has been through. 47. Says 42. It's close at least. Next one here is a 10. It leads to grab. This crocodile clip's a little bit dodgy on this one. Getting 11. And this is a 1 picofarad. We're seeing 4. Let's open that lead up, put it back in basically the same place, what we get. 0. Yeah, okay. Maybe that capacitor's not very good. I'll get a different one. There's a different 1 picofarad. Let's try this one. Nothing showing up. Okay, let's try 2. This is quite a challenge for any meter, this sort of level. Yeah, seeing 1 there. So yeah, it can read right down there. So I'm happy with that. Obviously once I've calibrated it, it'll be better. But right now, that's what we get. But so it's working across that ranges. I need to adjust it, get it all set up right, and get these readings correct. But it's looking like it's going to be good. Happy with that. It might be fixed. Now, I'm not going to say that yet because I haven't checked the inductance side yet. Need to do tests on that side, but the capacitance side now seems to be correct and working. So I'll just turn off some more of my lights so I can see a bit easier, so I don't have to keep covering the thing up like this. This is a 1 microhenry inductor. Push this. We're getting 1, exactly. That's working. Let's go to a 10. Which is about 9.4. Let's try another one. And I'll try it on the LCR meter I've got over there as well. See if that comes up any differently. This one says 9.3. Okay, let's try one of these on the LCR meter. It's not a big discrepancy, but there is one. Let's check it on here. And that's saying 8.9. So it is actually pretty close. And don't forget that's not calibrated either at the moment. I need to do the calibration on that to get that right. Let's try 470. Okay, 437. LCR meter says 478. So there's a bit of a distance out there. So that might need adjusting. So we've got these power coils. Stick on the LCR meter. 10 microhenries. 10.4. Yep, okay. That agrees. I kind of need a bigger coil. I need like a transformer to test to see if it's the higher capacities are okay, but the lower stuff's certainly working alright. So I think for now I'm going to call that a fix. I'm going to say that's done because it does seem to be functioning now and everything. Ringing test I haven't done. Well, I know I have had some ringing tests going on. Let's just do one on any random coil. Let's do one. Do that. Ringing test, yeah, I mean it's doing 4 rings. I mean, is it right? I don't know. But it's doing something, so that's probably fine. I think it's all fixed now. So I'm going to call it a win. And it took me a long time. Way longer than it should have done. At least I focused in the correct areas at the very beginning. I was worried about that counter at the back there, that 4017 IC6. I was worried about that being a problem, being the range selection. I was right to focus on that. Early on I was looking at those 2 transistors, but I wasn't quite sure what I was supposed to be checking for at the time. And now I've learnt more about the circuitry, I understand how those function properly and how they interact. So then I was able to go back and look at those after I've done some basic logic checks to make sure that, hey, things are switching like they're supposed to switch. Because it's kind of a bit of a loop as well, a bit of a closed loop system, it makes it hard to know whether the range issues was because of the reading of the range being wrong or the range control being wrong. It turns out it was both, so that made it harder. Anyway, it's fixed. I'm going to do an alignment on it, get it all tuned up, get it calibrated as best I can with the gear I've got here. I'm going to call that one a day. I mean, it's fully recapped, so this should last until the next IC blows up, I suppose. But I mean, it could last another 20 years easy. You expect it to. Videos to watch down below. If you want to see more repairs, subscribe over here, and Patreon support link over there to help me buy more test equipment like this to fix, do videos about. Yeah.